Morning. How are you?
Good morning. We're fine.
Good. Do
How
you have
about
a?
you?
I'm fine. Just waiting for the weekend. If you know the feeling.
Yeah.
I thought so. Do you have anything else today?
Yes, Project B.
Okay. I have to admit that at this moment I really don't remember how much did we go through about the matrices last time. Did we go with multiplication already?
Yes.
Okay, but not the determinants and inverses. Or did we go through everything?
I think we have also a lot of things from last course, and in previous lecture you just like reviewed all things together.
Okay, so you basically know these things. And you have used a MathCAD already. So, and the MATLAB is the only one unknown to you.
Well, more or less. Yes.
Some of them.
Okay. Somebody just wrote that not all of them is gone through. Here is the determinants, the basics of them. I think the main point is that when you are solving with determinant, you are actually solving the denominator. And the determinant is used to check whether there is a solution for the system of equation or not. If this equals to 0, when you do not have a solution or you have infinite number of solutions. So either case, if it's something else but 0, the determinant, then you have a unique solution. This is what is said in math. So for math, this is the most important part. Of course, it is used also when we are solving differential equations and so on. It gives us lots of more information. But for example, Seppo's courses concerning finite element methods and so on, the determinant has the meaning also there. I really don't know the words in English, but when you have a structure with beams, and for that structure you have to solve stresses and so on, you need to get a matrix. That matrix in easy cases, so for example, in our FEM we had four, I don't know, the Solmo corner points, and the matrices coming from there are at least 8 times 8. So if you have a bigger case, actual structure, the matrices are very, very big ones. And in those cases, the determinant, for example, tells you whether this structure is fixed or is it going to. The Finnish word is nurjahtaa, but I don't know what's in English. Hopefully Matthew or somebody else can help you in this one. But anyway, it has also the meaning in your professional studies. So for that reason, you need to know how to solve it. The formula given here is for 2 times 2 matrix. If you check your formula box, you can find a nice formula for determinants where you can solve it for any kind of matrix, any size. The problem is that the formula in my eyes looks just awful. If you have the matrix which is bigger than 2 times 2, so for example, here we have 3 times 3. To solve,
Excuse me,
yeah,
are you sharing us also the MATLAB? We just can see the MATLAB thing about the materials.
you see only the MATLAB.
Yes.
Ah, okay. I am sharing, yeah. I thought I was sharing my page, but probably I'm sharing something else because there is no MATLAB open here. That makes it very nice. If I share it now, can you now see my lecturing material?
Yeah, we can
Yes.
see it.
Okay. So what I was talking about previously, it was that the determinant is this part. So if this equals to 0, you either have no solution or you have an infinite number of solutions for system of equations. But it also have this professional field, which I have no examples here. Here is the formula for solving the determinant for 2 times 2. So it's so it's only this times this minus this times this. If your matrix is more than 2 times 2, like 3 times 3 we have here, you have to have 3 times 2 times 2 determinants to solve separately. So just think about when you have 8 times 8 matrix, you are going to have 8 times 7 times 7 matrices. All those 7 times 7 comes down to 6 times 6. So the number of determinants you should solve with paper and pen in that case is just enormous. So that's why I only show here what is the basic idea of solving these determinants. But when you use them in real life, you use the programs to get these. I know some of you have the calculators where you can solve matrices and determinants, but probably they are restricted so that it's at least somebody told me that 4 times 4 is the biggest one you can solve. So here are the formulas which you can use in programs. So for example, in Excel, you have to take the function. And in MATLAB, you can just write down that. MathCAD, it's just the absolute value signs. Or in MathCAD, you can also write down a det. Like here, you can write the same formula there. Inverse matrices, basically the same case. Here I just want you to show that the idea of inverse matrix is basically the same as the inverse number. All of you can solve this kind of equation, but if we don't solve a value 3 here, we can write it as the inverse of multiplier times the result. And the same case if you have this kind of a system of equation, you have the multipliers in the matrix, you have what should be as a result in a vector, and when you know AX a times the variables equals to b. So to get the result, it has to be a inverse of a times the b, and this is the inverse of a here. So inverse of a times the b, and you get the result. Value of x is 1, value of y is 2, and value of z is 7. So these are the basic ideas, and here you can see how this is done in the Mathcat and how it is done in MATLAB, the same case. Today we go through the MATLAB a little bit more, so you can actually do something there.
Maybe may I ask you? Does our university have license for MATLAB so we can download it to our computers or laptops?
Have you checked the virtual desktop two-dimensional cases?
Yeah, I checked the desktop, but I was like interested in the personal computers, not the virtual desktop.
Check the virtual. I think it's in there.
Okay, thank you.
I really hope it's in there because we need it. It was last spring, so why it wouldn't be there anymore?
Yeah, it is there. It's all right.
Okay, good. So these are the basic ideas. I don't want to use more time for hand solving of these because this is not the point at this stage of your studies anymore. Before you try to solve the inverse matrix, there may be the case you just want to check whether the determinant equals to 0 or not. If it equals to 0, then the inverse matrix doesn't exist. About the Mathcat, we are not using a lot of time for it, but did you already know that you can also get also all the substitutions to be seen? So when you are returning something to your teachers, if you use them in reports, they can actually see what is used as a number and so on. And you know how to use the equations when you solve it. You can use the values later. So are you familiar with these?
I'm not. Don't know if others are.
Okay. So at what kind of things you have done with the Mathcat?
Well, we used to do some kind of simple calculations, just define variables and then perform some calculations. And we also had some practice with Heikki, where he demonstrated us all the abilities of the program, but it was a year ago. And we hardly remember, but I don't think it's a really complicated learning process because the program is quite obvious. So
it isn't, but of course there are other things that for example, these things, how to get the solutions to be used later. It took a lot of time for me to figure out because it was not mentioned anywhere. So this kind of little things is there always. So that's why, but because you cannot use it during this course, it's not. It doesn't help you this course at all. Let's see. But you also know how to work with the units and so on.
Yes.
Yes, we are.
Okay. I think you can handle it. But the MATLAB is something not so familiar for you. Please open the MATLAB, all of you, so when we go through this one, it's much easier for you to check what is going on. Do you have it already?
My desktop's loading.
Okay.
I think we all have problems with loading the desktop. So.
So there is too many.
I have no problems, even with MATLAB or MATLAB.
Okay.
When did you launch it?
8 o'clock.
Okay, so maybe then you're lucky.
So if you already loaded at 8 o'clock, what you have done already with the MATLAB?
Like previous lecture, we do the matrix with the MATLAB, and
Okay.
also I have something have to be do with the report, so I just open and do it.
Okay. How do you feel about this distant learning? Is this better or worse or neutral compared to the contact lectures?
I think it's worse because like it's hard to uh, pay all the attention to the lecture, and the feeling is more lazy.
Yeah. So there is some problems in your self-regulation.
Yeah.
How about
Well,
the others?
Same.
Right. But on the other form, somebody has told me that, for example, these programs are easier to learn through this Zoom and so, because it's coming so much closer. And you can actually see what the teacher is doing. Just tell me when you are ready.
I think most of us are ready.
Okay. Let's start with the basics. What you actually need there is how to keep the matrices. So what you write here is that, for example, A equals just normal equal sign. And square brackets, you can give rows so that the elements are separated by space, or you can also use a colon. And with when you want to separate the rows, just the semicolon and then the new values. And when you are ready, just enter. So it's not drawing any kind of a matrix brackets here, but it's understood as a matrix. So we could actually do something. Let's do another matrix. The numbers doesn't matter, so don't use too much time for that. And now when I'm ready, you see I just put the semicolon here at the end and I push the enter. What happened?
Did it record to the memory?
So it didn't write the B here. So the semicolon is like, don't print this one to me. I already know what I have. If I just don't write it, it shows me. When you do something for the first time, writing it without this semicolon is reasonable because you can easily check that it's actually the thing you wanted. But if this is, for example, inside the for loop, then it would be reasonable to use this one because you don't want it to write the matrix B every time it's going through the loop. So it always depends on the case. And sometimes when you do the programs at first time, you don't have this semicolon, but when you see that that thing is correct, but you have to change something else, you may want to add false, so you don't need to check them all the time. The problem is that when you do the programs and you run them, all information, what you want it to print, is printed to this command window. We also did go through the idea of how to sum them. So just add A plus B without the equal sign, and you get the result of these two matrices. Also, if you want to have a multiplication of them, just put the product sign there and you get the result. It doesn't show you the intermediate steps. So for that part, you have to just figure it by yourself if you actually need. If you just want to check that the result is correct. And here probably you see that if I put matrices in different order, the result is also totally different. It has nothing to do with this one. So like I told you, the order in multiplication is very important. What do you mean, Sora, with can we edit the function? If you mean that you have noticed that you have some mistake here, you at your keyboard you have these arrows, and if you take the arrow up, you can get all previous commands. And if you wanna change the value here, just take it. But then you have to do also all the calculations once again. Did this answer your question? So this is the multiplication we did talk about during the last lecture. But if I write it like this, you see the result is totally different. So this is not a matrix multiplication. What happens here is that it is multiplying the corresponding elements one by one. So if I put the B here to be shown, you see it is this one times this one here. 2 times 2 equals to 4. 8 times 2 equals to 16. So it's a different kind of product. If you need to get the determinant, you can use this. It solves it just like that for you. And if you need the inverse matrix, you get it like this. Is there anything you want to ask so far?
If you try to multiply unmultipliable matrices, will it just output an error? Or
let's change the A. I just write down here one row more. As you see, I did have one element too much. It told me that it's not correct. The dimensions are not correct ones. So these error messages are very important and they give you a lot of information. So now I have the A 4 times 3 matrix. And if I want to have, for example, so it's not transpose of A times B. It tells me that the matrix dimensions are not correct, so it cannot solve it. Because if I take the transpose of A, it's 3 times 4, and when it's multiplying it with B, we have only 3 elements here on the column, but 4 elements in a row. So it's not possible. And these kind of things, I am quite sure, happens to you when you are actually doing the things, because it's so easy to miswrite or misunderstand the things. It happens to me all the time with working with programs. So for that reason, but the messages, they are good and they tell you a lot. You also need to plot things, so you need to get the graphs, and for that reason, let's see how it happens. Now I have to admit that I haven't used this one for a year, so it may be that I just don't remember what happens. So it cannot be given as a function, it has to be given as, yes. So we have to start it totally differently. So we have to start from the fact that t has the values. So we have to give a range for t. And if our range is from, for example, from -5, and we want to get the values after every half point, so put 0.5 here and then end at 10. You get all the values for t. And when you have this one, you can also get values for f at those particular points. And as you see here, it tells me that the problem is with the power, because I don't want to have a matrix product. I must put the dot here. So it, not here, before the power sign. So it is a square of this one, square of this one, all of them separately. And now we have all the values of a function. Just say if you are behind, I have time to wait, but if you don't say anything, I assume that you have done everything what I have done.
Yes, and how can we bring a graph in here?
I was coming to that one. So when you have T and F, you can use the plot. And it already shows you how. I would say just G and F return here. At least it starts working. And what I got is this one. So MATLAB is a numerical program in the sense that you always has to have a numerical value before you can solve anything. If I would like to have this instead of blue as a green one, I just put the G in there. If I just don't want it to be the line, I want to have there, for example, the mark instead. Okay, it doesn't like that one. Now where is the asterisk? It changes how it's done. There is a possibility for also for three-dimensional plots and so on, but because you don't need them during this course, I don't use the time. I am just checking whether some of these there is no, they are all something else. And those are the ones where you can actually check from the other side, so you can turn the graph also. So they are quite informative. Basically, this is the basis. The problem with working in the command window is that you have to do everything little by little, and it runs the command right away, and it's not working like a program. So if you need to do a program, you take a new script from here, right upper corner, left upper corner, not right, left. And you should have this kind of editor there. And basically, you can now do the same things here, but this is a file which you can run as one. So when you write the formulas here, nothing happens before it's been run. And also that you can save this file for later use. Basically, all what you have done here, if you don't clear the command window, you can see them also later. But like for me, I usually just empty it, and I don't know how long they stay there. So it may be that next time you can have them, but at some point you just want to clear it, because if you have too many commands with the same name, you don't actually anymore know which one was the latest, because the program always use the latest one. So for example, here, if I just want to give that I have something with the length of 2 meters, I cannot use the units. I just give L equals to 2, but with the percentage sign, I can write a note to myself that it is meters. And when you are doing the numerical exercises for me and programs, write these comments and comments there. So it's easier for me to follow your program. And with these comments, you can also write down the analysis of your results. So there is no need to give a separate file to return. I can also have that the time is, for example, 10. So that was in seconds. And now, because I know the length, I know the time, I can solve that my speed is L time divided by T. If I want to see the result, I don't write this semicolon. And now you can run this one. Easiest way is taking this one. As you see, it is saving and running the file at the same time. So if we push this one, it's asked to be saved. If you don't save it, it doesn't run it. I am not giving any name here, but if I were you, I would give, if you just want to have it later use, I will delete this file anyway after this one. So I save it as an untitled. Please remember that the file name cannot include any kind of basis, and no very special marks. Finish a as is not allowed. So this should be simple and quite short. When I save it, it runs and gives the results for me. Now I have seen that L, T, and V seems to be the correct. If I need them later in the same file, I just add this semicolon so I don't see them all the time here. Here you can also write down the matrices. Now I just get this value file for us. So this is about these silver things. And I write down, and here will be semicolon, of course, write down the matrices. And here, because it's not running any commands, it doesn't even tell us whether we have mistakes or not. And because these are at the different rows, I have to put this semicolon. And now I know that the result should be inverse of A times B. I have saved this file, everything is inside the same file, and I just run it. And we can see A seems to be correct, B is correct, and it gave us the correct result. Now, if I need only the value of y, I could say that give me the second of x. What you are going to need when you are programming is a for loop, and in for loop you see when you start writing something like this kind of loop or function, it's written in different color, and in our case it's in blue, and this is just easy way of showing you what happens. So from E starts from 1 after every 2 till 10. Uh, write down E. I remember that it should require do here, but it's not doing a thing there. So it has to be on with a different line when it's recognizing it. And if I run this one, we see it, nothing happened. And this is the good one. It says that at line 12 and column 1, the mark 1, there is a mistake. When it continues, that end is missing. So it's not saying that this is totally incorrect. It's just telling us that we didn't have the end. And we actually don't know whether this one is working. But if we run it right now, you see it goes from 1 to 9. It's not writing them into any kind of a vector or matrix. It is just writing them all separately. But if you need them, you could have that point E equals to a value of I. Now we have, it's going to write down the vector point E. So now in the point you have all these. Do you know why there is zeros? We didn't ask it to write zeros.
Empty values, maybe.
Yeah. So if you wanna have, but it's all like this, just take the middle part away, and now it gives all the values. You can also have these plot things inside here. And once again, I did take the incorrect formula. As you see, it's very easy to write different things. I was thinking about f, I was writing x, and it caused the problems. And now, no error messages, and the function is also in the figure. I was just thinking, was there something? There is one program what we have done during the finite element methods. Here is some kind of structure, and the matrices based on that case, and all. Anybody who knows what is jäykkyysmatrice in English? No one? Let's see. Oh, stiffness matrix. Does it say anything to you? But anyway, there is the local stiffness matrices here separately, and then for the whole structure, and when we have solved how much does this different points move, and into what kind of direction, and what kind of stresses are there, and so on. So actually, what is done here with this quite small program is exactly the same thing what the Yiki is, for example, doing. So this helps you a lot if you know how to program this kind of things. If we check, I think you already have a lecturing book open. At the end of this inverse matrix lecture, there is the example of forces, example 2. There is 2, 3, 4 forces. This kind of case, so let's have it here. So there is 4 forces acting to the point A, and it should be in balance. So we want to know how much is the force 1 and how much is force 2. And then there is the system of 2 equations given here, how to find the solution, and then it is also solved here. Now what I want you to do is to do a MATLAB script in the editor window to solve this one and to get this result from there. I'll let that one be there for you. Anybody getting a solution?
I am doing it.
Anybody got the solution? You are so silent that I am a little bit worried.
Uh, I have done it. I think it's correct.
Can you share your solution?
Yes. Can you see my MATLAB?
But
And this
okay, yeah,
this is correct.
yeah. It's correct. What is good here that you find out that you have to add a d if it's given in degrees. So there is no need to change them to be radians, just because the normal cos is solved from radians and cos d from degrees. Is there anything somebody else would change?
What do you mean? Like
I don't say it's incorrect, but there is something I would do differently just to make my life easier later. But I just want to see if anybody else figures out what it is. Can you close this one? I share my own solution.
yes.
I also wrote it. So you did write these angles here. And if I say for you that it shouldn't be 163, it should have been 63. Now you should go and make the changes everywhere. For me, it's enough to do only here. So what I'm trying to tell you, that try to keep all constant values here at the beginning, because if they need to be changed, you don't need to go through the whole program and remember there is actually that value. So for example, in my case, it was enough to do here, and now it changes it everywhere. So your file, your program was correct, but it could be done a little bit more sophisticated way. Also, with like here, we've noticed that you need to have this D. You also need to check what are the logarithms. So if I take log 10 here, I get 2.3. And if we have a 10-based logarithm, value should have been 1. So we now know that here log refers to e-based logarithm, not 10-based. All these kind of things you have to check, because these are the mistakes, and I do this mistake all the time because I don't remember it. But these are the mistakes where the program is not saying anything for you, and on the other hand, it's not easily seen. Same, it would solve the cos 163.7, but it wouldn't be from degree. So you would get different solution. Is there anything you want to ask about the MATLAB?
I'm not.
Is there anybody else still here? They are just silent. If not, I think you have some report to return today. I let you to write that down, and I go to the lunch because I have a meeting starting. And we can also go through some ideas when we start doing the actual numerical methods. But at least now you know that basically do everything here with the script. If you are not sure about the command, you can try it here at the command window and you can find it. Help is a good, use it. If you use functions written into the MATLAB in your programs, be sure that you write down what the function is and you actually give the correct information there, but also that the function is giving the correct case, because in many times I'm saying that you have to use this method and that method may not be written in the MATLAB. So if you use pre-written functions, check that they actually give the correct case. All right. Now it's time to ask, or otherwise I will end the lecture from my point. No questions. I see you next week, and next week we start doing the numerical methods. So we start from interpolation and extrapolation. Have a nice weekend.
Yes, thank you. You too. See you.
See you.